In this video, we're going to look at an introduction to parametric equations. So if we just look at the definition, parametric equations are going to have a third variable called the parameter. So we're going to see some equations x equal to a function of t and y equal to another function g of t, where t is another variable called the parameter, and the ordered pairs that we get with x and y create a plane curve or parametric curve. So let's go ahead and take a look at an example. We've got x equals t plus 3 and y equals the absolute value of t minus 1. So we've got our two different equations, x equals and y equals, both in terms of our parameter t. Now we're sometimes given a range or domain for where our parameter lies. In this case, we're just going from -2 to 2. So we're going to look at the integers from -2 to 2 for t and what our x and y values are, so that we can take those ordered pairs and put our graph together. So if I go ahead and look at my first equation for x, I'm just taking my t value and adding 3. So when t equals -2, x equals 1. When t equals -1, x equals 2, 3, 4, and 5. Okay, so now I have the x value for my 5 ordered pairs, and I need my y value first before I can do anything on my graph. So I'm going to take my t values again. Now I have to take the absolute value of t and then subtract 1. So absolute value of -2 is 2, and then I subtract 1 and I get 1. Absolute value of -1 is +1, -1 is 0. Absolute value of 0 is just 0, -1 gives me -1. Absolute value of 1 is 1, -1 gets us another 0. And absolute value of 2 is 2, -1 is 1. And so, not surprising, I've got some symmetric points there with my y values because we were dealing with an absolute value function for y. So now I've got my 5 ordered pairs, and so I can go ahead and graph those ordered pairs. Notice how this t value isn't going to be represented on our graph. It's a way to help us find what our x and y values are. So I've got 1, 1, 2, 0, 3, -1, 4, 0, and 5, 1. And now this gives us what appears to be an absolute value function. Notice how we can't put arrows on the end of our function, even though it looks like it's absolute value, and it typically goes forever. We're limited in what our parameter gives us. It's just from -2 to 2. So our graph is only going to go from between these points. So that's it. There's our graph for this parametric equation. Now let's say we're looking kind of outside this box, and we're asked, what is our y value when, let's go over here, when x equals -12. Well, it seems like it might be kind of tricky because we've got now 3 unknown variables in our equations. So I'm just going to go ahead and take what's given, that -12 for x, and I'm going to plug it in or substitute for x in that first equation. Okay, so now I've got -12 equals t plus 3. I also have y equals absolute value of t minus 1. That hasn't changed. So now I'm down to two variables, and I notice in my first equation, I only have one variable. I just have a t. So I can take that equation and solve for t, and then go ahead and substitute that value in my second equation to find the y value that we're being asked. So if I subtract 3 from both sides here, I'm going to get a negative 15 equal to t. Okay, so now I can substitute that in for t right here. So now I get y equals the absolute value of negative 15 minus 1. Absolute value of 15 is a positive 15. Subtract 1, and we get 14. Okay, so when our x value is negative 12, our y value would be 14. So if we're adding that to our graph, we're extending our graph based on this t value, or really the x value that we are given. We could also plot the point negative 12 comma 14. All right, last thing we're going to look at is how do we eliminate the parameter. So how can we combine our two equations and get one equation written in terms of y, written for y in terms of x. So go ahead and write this. Okay, so it's kind of similar to the problem we just did, where we were solving for y given a certain x value. And again, we want to eliminate this parameter t. So we want to solve for t in one of our equations and substitute in to the other one. Well, I noticed that in my first equation, I've just got a t by itself. And so if I just get rid of this plus 3, then I'll have t alone on one side of the equation. If I were to try to solve for t with this equation, it gets a little bit more complicated because we have absolute value around it. Plus, since we're trying to solve for y, it makes sense to leave this as y equals and try to substitute in for this t here. So if I go ahead and subtract this 3 over, I end up with x minus 3 equal to t. Okay, so now I'm going to take my x minus 3, and I'm going to substitute that in for t in my other equation. So now I've eliminated my parameter, and I have y equals absolute value of x minus 3 minus 1. And if we compare that to our graph, it's an absolute value function, which is what our graph appears to be. We have minus 3 on the inside, so that tells us a shift of right 3. And then with a minus 1 on the outside, shifted right 3. And minus 1 on the outside tells us that we're going to shift down 1. If we shift right 3 and down 1, that gives us our vertex that matches our graph. And this equation would have our graph go to infinity in both directions. But again, because we had our parameter set between negative 2 and 2, that's our graph. But it matches the equation that we found.